If two angles on one side are the same in two triangles, then the triangles are congruent. What does that mean? Well, here we have two triangles. We can see that angle A is equal to angle A prime. In this case, A is 37.18 degrees. We also have a second angle that's the same in both triangles. I'm calling them B and B prime. In this case, B is 109.13. We also have a side that's the same. So we're given that we have a side here of length 4.66, and in the other triangle we also have a side of length 4.66. These two triangles are set up so that they always remain congruent to each other, even as I change the values of the angles and the length of that side. So we need to have two angles the same in both triangles. Well, actually, if two angles are the same in two triangles, then the three angles must be the same, because the three angles sum to 180 degrees. So I could have rephrased this as saying, if the angles and one side are the same in two triangles, then the triangles are congruent. I don't have to state that two angles have to be the same. I could just say if the angles are the same. Because if two angles are the same, then by default the third angle has to be the same, because the three of them add up to 180. But anyway, this is usually the way it's stated. Now, the abbreviation that's often used for this condition is ASA, which stands for angle, side, angle. So we have an angle, side, and an angle, the same in both triangles. But of course, we could replace this abbreviation with side, angle, 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 or angle, 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 side. So the three A's refer to all three angles. So we just need to have that the two triangles are similar. Similar means the angles are the same and one side is the same. So these two triangles are similar. Now I've shown this particular side in blue as the same in both triangles, but of course I could have used this side here. So we just need to have one side the same in both similar triangles for the triangles to be congruent. Remember, similar means the three angles are the same. Now, in a previous video I said that if two triangles are congruent, then we could pick one of the triangles up and place it down on top of the other triangle, and it would fit exactly on top of the other triangle. Now I can't do that here by translating this triangle across in the plane. But what we can do is imagine picking this triangle up, turning it over and putting it down on top of this triangle. As a matter of fact, I constructed this triangle over here by getting the axial symmetry of this triangle in this line here. So it's like you can imagine rotating this triangle out of the screen over this line, and this triangle will then land down on top of this triangle.